All right, guys, we're going to finish up your Quadrilaterals Jamboard. If you've already done this slide, that's great. You can just check your answers. But I'm going to go through these. This is slide 19. First thing you want to do is not just plot the points and look at it, but you have to actually prove what you think it is. So after you plot the points on number 15, it looks like it could be a rectangle to me, or it could just be a parallelogram. We have to kind of figure that out. So the first thing you should do is find the slope of each side. So if I find the slope of this side AB, that's 1, 2, 3, 4, up 4, 1, 2, 3, 4, 5, 6, over 6. Then I want to make sure that it's parallel, or that it has the same slope, parallel lines have the same slope, as DC. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So these are both up 4 over 6, rise over run, so they're parallel. That also tells me that if these were a right triangle, this would be my right angle, this would be my right angle, the hypotenuse of that would be the exact same. So that tells me that the length of AB is equal to the length of DC. Now I need to find the slope of my side here, BC, 1, 2, 1, 2, 3, so over, up 3 over 2, and then 1, 2, 3, 1, 2, 3 over 2. So these are also the same slope, which means they're parallel, and they're the same length. So we have two sets of parallel lines, two sets of congruent opposite sides. So opposite sides congruent, opposite sides parallel. And so it's either a parallelogram or a rectangle. Then what I can check on last but not least is to see if these slopes are opposite reciprocals of each other, so that they would be perpendicular, which would give you right angles in the corners here. So if I have 3 over 2 compared to up 4 over 6, and we want to see if those are opposite reciprocals. This is actually negative 3 over 2, sorry, because I went down 3 over 2. And these are, because 4/6 would reduce to 2/3. So negative 3 over 2 and positive 2 over 3 are opposite reciprocals. So we have 4 right angles, which makes this a rectangle. So you would do the same thing on the next. You would do the same thing on the next one. You would find the slope of this and the slope of this. You can almost right away see that it's not going to be a right angle, so it's not going to be a rectangle, but it could be either a rhombus or just a parallelogram. And we can figure that out by seeing if these sides are equal. All 4 sides have to be equal. So 1, 2, 3, 4, 5, 6. That's up 6 over 2. And this is 1, 2, 3, 4, 5, 6 over 6. 1, 2, up 2. So that means if both of these have a length of 6 and 2, then when we do a squared plus b squared equals c squared, we're going to get the same length for these two lines, which means these are the same length as well, which means that this is going to be a rhombus. For these down here, you can very easily visualize what you think it is. I think this is a square or a rhombus, or I guess it could be a kite. So same thing, 1, 2, 3, 4. This is over 4. So up 3 over 4, or down 3 over 4 actually. Negative 3 over 4. And then this one, 1, 2, 3, 1, 2, 3, 4. So these are parallel. Okay, which means they're going to be 1, 2, 3, 1, 2, 3, 4. So this is over 3, up 4. 1, 2, 3, 4. And 1, 2, 3. This is up 4 over 3. And so these are opposite reciprocals, which makes these right angles. So this would be a square. This one we think is a kite. For a kite, this side, this leg, should be equal to this side. They share a vertex angle. So I can count these. This is 1, 2, 3, and this is 1, 2, 3. So those are equal. Then we would want to check to see if these two are also equal. 1, 2, 3, 4, 5, 6. This is up 6. 1, 2, 3, 4. That's 4. So if this is a right triangle with side legs of 4 and 6, and this is 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So that's 7, and that's 3. So these are not equal. Let me make sure I didn't count wrong. So this is over 4, down 6, and this is down 3 over 7. So not a kite. This one, we can see that the slope of this and the slope of this are not the same. This has a slope of up 1 over 2, and this other base would have a slope of 2, 3, up 3, 1, 2, 3, 4, 5, 6. Up 3 over 6 is the same as up 1 over 2 because they reduce to be the same thing. So these are parallel bases. And these are not parallel legs, so it's not a parallelogram, which means it has to be a trapezoid. Okay, and then I'm going to show you the answers to the previous slides as well, so you can check your work. Go one slide back, and here are the answers to slide 18. You can check them. Push pause if you need to. Here's what I have for slide 17 and slide 16.